today's LeetCode problem. So this is LeetCode medium, and the question is the kth largest sum in a binary tree. We have given the root of a binary tree and a positive integer k. The level sum is in the tree is the sum of the values of the nodes that are on the same level. Okay, and return the kth largest level sum in the tree, not necessarily distinct. And if there are fewer than k levels in the tree, return -1. So basically, if you read the question, it's a very understandable description is given. So where we have given the kth largest, we need to find the kth largest level sum, right? That's what the conclusion of this question. And what the kth largest level sum, so at each level we need to find, we need to sum all the elements, we need to sum all the elements at each level and find the kth largest all of them, right? among all of among all of the sums, right? So that's the whole question is needed, is asking. And one thing is to note that if there are fewer than k levels in the tree, return -1, right? So this we will remember, right? Let's make this in a point, return -1 if the levels, the count of levels or the number of levels is less than k, right? We will make this as a point. Now whenever you find, whenever you find one thing, okay, let's discuss about the example. That in this, if you see this tree, the first level is 5, the second level is 8 and 9, so 8 and 9 is 17. The third level is 2 plus 1 plus 3 plus 7, which is 30, and the last level is 4 plus 6, which is 10, right? So if you need to find the second largest element among them, which is the second largest element, of course 13. So that's the answer, right? So basically we need to check each and every element at each level for that, right? And whenever you find anything related to the level sum, right, anything related to level sum, you must remember level order traversal for that. And for level order traversal, what we do, we simply use q data structure, right? We simply use q data structure. If you have not, so if you not known level order traversal, I must tell you to understand it properly and then solve this problem, otherwise it will be difficult for you, right? So basically now if you see this level of traversal, we use q data structure. In this, what we do, we move level wise, as per the name suggests you that it we move level wise and check each element for each level, and check each element at each level, right? How this works, it just uses q data structures, which is first in first out, right? First in first out, it's FIFO, right? It's FIFO. So if I simply make this try run on this example which is given 5, 8, 9 and something like, so if I see the first thing is in q data structure, when I start moving, you will see that first element is 5, which is the root element, right? Its next and the right element is 8 and 9, right? So this 8 and 9 is at the same level, it is at the same level, right? This is at the first level and this is at the second level, right? Same goes for 8 children is at 2 1, 9 children is at 3 7, which is 8 and 9 children, which will be at the third level, which is 2 1, this 3 and 7, this is at the third level, right? So if you see that what is happening, that at each step, at each step that their children's, all their children's are at the next level, right? So that's what we gonna use in q data structure, that the root children is at second level, the the second children's sub children's are at the third level, and the third sub to sub children's are at the fourth level, which is 2 children is 4 6, so we will insert 4 6. Same, and 137 has no children, so we will not insert it, so this is the fourth level, right? And if you observe here, we are taking summation of this 5, this 8 and 9, this 2 137 and this 4 and 6, so which is equals to 5 9 8 17, 2 1 3 7 is 3 6 6 and 7 14 is 13, and this is 4 to 4 and 6 is 10, right? Among these, we need to find the kth, we need to find the kth largest element, kth largest summation. And how we find the kth largest summation? The first approach is, if you have solved the kth largest heap, it is same thing as to find the kth largest element in an array. Now its question changed to, after finding the summation, it changes to kth largest element in the array. So what are the approaches? The first approach is to store all the sums, to store all the sums, all the sums in an array and sort it decreasing order, sort in decreasing order, and return the kth smallest element, kth largest element, right? Kth element, because we have sorted in decreasing order, so we can return the kth element, which will be the answer, right? This is the first approach. The second approach is, instead of storing in an array and sorting in decreasing order, which can take o of n log a of n, right? O of n log of n. Here n is, I'm taking at take its m log mf, where m is the level of number of levels, level size of tree, right? Let's take this. So this is the possibility when we use array, right? The second approach is using heap, right? And which heap? Using min heap. How does it help? It will store, it will store all the elements, but till where? Till I have the size of k. What does it mean? Let's analyze this, right? So this is the same problem, the find the kth largest element. If you have solved this, this is very easy, right? So one thing is to clear that, suppose we have given 4, 8, 5, 10, 2, 7, right? We need to find the kth largest element, and k is given as 3, let's suppose, right? When we use min heap, right, we need to find kth third element. So suppose I am inserting the numbers here. So in my min heap, and what does min heap give? Min heap gives the top element will be the smallest element among all of the elements, right? Smallest element will be the smallest element among all of the elements present, right? So that's what min heap gives, right? So when we insert this 4, 4 is, so pq size is still less than 3, okay? So we can insert it again 5, then insert it again 10. Now when we try to insert this 2, so we will insert it, but its size is greater than k. Now pq size is greater than k. It means one element can remove, we can remove one element, because we need to find the kth element, which is the third largest element. And we are overflowing, right? We have the size of mean heap greater than this k. So what we can do is, we can remove the top element. And when you remove the top element, it will remove the smallest element present among them. And what is the smallest element? That is 2, right? So we can simply remove this 2 among from here, right? Now now pq size is equals to k. You can again insert 7 here. When you insert 7, now it is again greater than k, right? So you can again remove one element. And what is in this time, which number will remove? This times it will remove 7, or no, sorry, it will remove 4. Why 4? Because this is the smallest element. Now we have three elements in my main heap, and we need to find, and we don't have any other elements left in my array, right? Now this 5, 10, 7, we can simply see the top element, which is 5. And if you observe, this is the third largest element present in this array, right? First is 10, second 7, and third is 5. Why is it working? Because it is working because we are just maintaining the largest elements of an array of size k in main heap. That's why it is working, right? If you same can goes to the minimum element, the kth minimum element if you want to find, and you can use the maxib for that, right? For maintaining the smallest element, smallest kth element of an array you can find in maxib, right? So this is the two approaches. What it will be benefited. So previously it was taking m log of m. Now it will take only of o of m log of k. Why log of k? Because each insertion takes log of each insertion take log of the number of element is present, and total number of elements at any point of time is present only o of k, which is o of log k, right? And we are inserting n elements, which is this m, so that will be m into each insertion takes log of k, so that will be o of m log k, right? So from m log m to m log k, we have optimized this further. So we are using this mean heap in our approach and this level order traversal. So basically this question is now changed to level order traversal, which is using q plus max min heap, right? Right, which is q data structure plus priority queue, right? Now when we start from this 5 8 and 9 and 7, and this is q here in this case. So this is how we will find it. So whenever we get any elements present in the at any level, we will insert in our priority queue, like this 5 then 17, and we need to find the kth as 2, so which is 5 17. Now when you try to insert this 13, this is pq dot size is greater than k, right? Now this will be, we need to remove one of the element, and the smallest element is 5, so we can remove this 5, and the left element is 17 13. Now we again get 10, so when we insert this 10, the size is again greater than 2, so we can remove this 10, right? So now when we see, we have the size of k in my pq, and the top element will be the kth will be the kth largest element, right? Which is equals to 13, and that's our answer in here case, right? One thing is to note that it is also possible that there are fewer than k levels. So at last we will first check that pq dot size should be greater than k, right? Otherwise if it is less than k, we will return -1. We will not return pq to top, right? We will not return pq dot top, right? So this is how we solve this question. Let's just implement it, you will better understand. So let's just use a queue data structure for that, which will store our tree node. Also we need using a mean heap, which is a priority queue. That will take long, because why I'm taking long, because it can summation to, it will go not go out of bound, and this is vector long, and this is a greater end, right? And this is pq. Now we will insert root element in my queue, and we will iterate in level order traversal. So for level order traversal, what were doing, we were iterating to each children at each level, right? So the first element is from q dot front, that was the first element, and we will remove this. Now we will check. So for each level, if you see here, in this case 5 give 8 and 9, 8 and 9 gives 2 1 3 7. So at each level it is storing the number of children, right? So we need to find at each level that what is the size of this queue data structure at each level, right? And we will iterate accordingly, right? Now what we do, we will see that this size is node, and we will insert this left child and the right child as the same in my queue data structure. What I'm doing, I'm iterating at each level. At each level there is a fixed size, which is the number of elements, and at each level I'm just storing its children. So for 5 it will store 8 and 9. For 8 and 9 it will store 2 1 3 7. So the first element size is 1, the second level is 2, the third level is 4. That's how it goes, right? So the node dot write is q dot push, and this is node dot write, right? Now also we need to remember, we need to find summation. We just not need to level order traversal. So what we will do, whenever we find an element, we will just takes its value and take summation of that value, right? At last, after this level is completed, so this represent a one level, right? So whenever my level is completed, I will store my summation value in my mean heap, and when mean heap size is greater than k, the same thing happen, we will pop the top elements from it, right? At last the element which is at the top of the element will be my the kth largest element. But before that we need to remember that it can happen, it the levels of the number of levels of tree is fewer than level. So we need to check further that pq dot size should be less than k. Otherwise, if it is less than k, it will be return -1. Otherwise, we will simply return pq ka top element, right? This will give me the kth largest element. So this is a main heap. And this is for level order traversal, right? Let's just try to run this and hope I have not make any compilation error. Yeah, I have made one compilation error. And what is that? This is while size minus minus. Okay, this should be size. Let's try to run this again. Okay, semicolon. Let's try to run this again. Still, we have passed all the sample case. Let's submit it. So if you see, we have passed all the test cases. Now we will discuss the time complexity, right? So one thing is to clear that we are iterating for each and every element. We are moving to each and every elements of the tree. So that will definitely take O of n, right? That will definitely take O of n. And for each element, we are inserting. So that will be O of n. And for each elements, for each level, we are inserting the summation in our mean heap, right? So that will definitely take. So for there are total number of levels, total number of total number of levels can be possible is O of n. Why it is possible? Because it is not given that it is a balanced binary tree, right? It is not given, it's just given this it can be a tree. So it can happen that for each element there will be a tree at each level, right? So it can happen that each level it can be possible O of n. So that will be can have log of, for each instance that can be have log of n, right? So the, and for each priority key we have the k elements in our there. So this can goes to log of k, right? And if you see the k can be n, so at the worst case, right, at the worst case it can happen that it will be o of n log of n, right? So this is the time complexity for this problem. Otherwise it will be o of n log k if it is a balanced binary tree, right? And the space complexity, the same is min heap, which is o of k, because we are maintaining k elements in our main heap. And for number of elements which will inserted in q data structure, that will be also can goes to o of n. So that would be o of n plus k, right? So this is the space complexity and the time complexity for this problem. Hope you understand it.